Hi everyone, let's work together on some applications of linear systems, or as we call them, the word problems. Now, remember that every word problem tells a story. So the first time you read the problem, you just want to understand what the story is about, or what the situation type and what kind of questions are being asked. And then read it again carefully, but this time focus on important numerical information. And if possible, try to identify what is known and what is unknown and write this information down clearly. Now, next, your focus will be on the question asked, and usually, whatever is in the question will be identified as the variables x and y. Remember that linear systems contain two variables. So, in your word problem, you'll be able to identify the two variables, and we normally use the variables x and y, but this is not a must. Now, organize all the information and try to translate words into equations. Once you form the system of equations, then you solve it. And lastly, you have to interpret the solution, or as we call it, the therefore statement. So let's get started with one practice question. I'm going to read this for the first time. The sum of two numbers is 176 and their difference 48. Find the numbers. So first time I read it, I understand that this is a number question. Now, next I'm going to read it thinking of what I'm given and what I'm asked to find. So in other words, we have to read the second time with purpose. And now we know what our purpose is, to find numbers, right? Missing numbers. So we have two numbers and we have to find the two numbers. So writing the question is where the variables are. So we're going to let the numbers be x and y. So we start off with therefore statements and we write them in this particular format. Let the first number be x and the second number be y. Once we have a name for the unknowns, we read the problem carefully one more time, trying to connect these variables with the information given. So if we're told that the sum of two numbers is 176, here we are translating words into equations. Sum means addition. So addition of the two numbers, so addition of x and y, means equals in math, and 176 will be their value. So what that means, in other words, is that the two numbers x and y would equal 176. Now, their difference, so whose difference? Well, x and y difference. So we're going to say the difference between x and y is x minus y is, here goes is again, equals, and then the value is 48. So with this, we have formed two equations, and they both contain the same variables x and y. So we'll put them together and solve it. So x plus y is 176, and x minus y equals 48. Next, we'll think of the method of solving it. And when you solve word problems, it doesn't really matter what method you use. Obviously, you don't want to use graphing because that can be a bit complicated depending also on the given numbers. And substitution can sometimes be complicated if you have big coefficients. Now, elimination is my way to go for solving the systems of equations, but substitution in this case would be easy as well because all variables have the coefficients of either 1 or negative 1. But I do notice here that the variable y has opposite signs here, so I am going to solve by elimination, and that will happen if we add the two equations. So the elimination of y will happen if we add the equations, the first and the second, because y plus negative y will be 0. So here we go, x plus x, and then plus y plus negative y equals 176 plus 48. Oops. So here we go. Plus y minus y will simplify to nothing. And we are left here with 2x equals, so 176 plus 48, 8 plus 6, 14, 7 plus 4, 11, a 2, and 224 would be the sum. So now we have to isolate x. Think about it. X is being isolated from number 2, which is multiplying it, which means that the way to get rid of it is by doing the opposite of multiplication, which is division. We'll divide both sides of the equation by the same number, by number 2. And here we go. We have x all on its own. 224 divided by 2 is 112. So once you find y, then x, you can determine y. You can use either the first or the second equation for the variable y. And I'm going to use the first equation, equation A in this case. So because y is positive, and hopefully I won't have a lot of work to do there. So x plus y equals 176, or now that I have x, I substitute it by 112 plus y equals 176. Isolate y. Now this time we are adding a number to y, so the way to get rid of it is by subtracting 112 from both sides, or as we call it, take 112 to the other side, but remember to change the sign of it. And here we go, we have 176 subtract 112, 6 minus 4, 7 minus 4, so 64 will be the number y. So we figured out the x and the y values, and now we have to think, what do they represent? Well, x is the first number and y is the second number. So it's time for us to move to the last step, which is interpret the solution, or as we call it, write the therefore statement. So these 3 dots mean therefore, and we're going to say that therefore the two numbers are 112 and 64. So in the next question, you have again another number question, but this time we're using numbers to describe age. So we also call them the age questions. So you can try this on your own, and I'm going to go over it with you. Follow if you would like to listen to the solution or check your answer. Now, Luke's age is 2 less than twice Peter's age. Okay. The sum of their ages is 37. Let L represent Luke's age and P represent Peter's age. You wish to know their ages. Write a system of equations to model this situation. So I read the problem the first time, and I understand that this question is about finding the age of 2 people, Luke's and Peter's. Now this time we are given the let statement, so L is going to be the age of Luke's age. All right. And P will be Peter's age. Now I'm going to reread the problem one more time, and this time I will try to connect these variables with the information given. Now, Luke's age is 2 less, so when we say 2 less, it means that we are subtracting 2. Then twice Peter's age. So think about it. So we're subtracting 2 from twice Peter's age. So twice Peter's age will be 2p. So when we say Luke's age is L, is means equals. So we are subtracting 2 from Peter's age, so but double of Peter's age, so 2p minus 2. So therefore, we're going to say that the first equation that we can create from this first sentence is that Luke's age, L, equals 2p subtract 2. Now, the sum of their ages is 37. So when we say sum, we mean plus. Their ages are L and P. And when we say is, means again equal, 37 is the value of it. So this would be the system of equations. Now, whenever we solve systems of equations, we want to write them in the form ax plus by equals a number c, a constant, so no variables. So if you want to solve this system by elimination, then we're going to take 2p to the left side equals negative 2, L plus P equals 37. And if I want to still use my elimination method here, then I would choose to eliminate the variable L because they have the same coefficient, but because their signs are the same, this time we are subtracting. So we're going to say L subtract L minus 2P and then subtract P equals negative 2. Okay, I mean to make this blue. Subtract P equals negative 2 and then subtract 37. So L minus L is no more L. Negative 2P minus P is negative 3P equals negative 39. So isolate P from number 3 and we get 3 negative and we get P equal to 13. So if P is 13, then we can find L, which is 2P minus 2, or double 13 minus 2. So that will make 26 minus 2, or 24. So L is 24. So therefore, we're going to say that P, which represents Peter's age, is 13 and Luke's age is 24. So therefore, Peter's age is 13, so Peter is the younger one, and Luke is 24 years old. Okay, and I hope that everything made sense. Thank you for learning with me, and bye for now.